Hello, everybody. Today we're actually going to start Unit 2 on analyzing two variable data, not to be confused with Unit 1, where we were just talking about one variable data. So today we're actually going to cover two topics. The first one's going to be relationships between two categorical variables. So there's a couple different definitions that we have to remember, and I'm sure you've heard a couple of these before. The first is a response variable measures an outcome of a study, and this variable is sometimes referred to as the dependent variable and is typically symbolized with the variable y. Okay, if you guys remember, on an xy axis, this would be the y-axis and the x-axis, just in case you forgot. An explanatory variable attempts to explain the observed outcomes. So explanatory, explain. This variable is sometimes referred to as the independent variable and is typically symbolized with the variable x. Let's move into an example. So example number 1, we're going to identify the explanatory variable for the following relationships, and we're going to explain our reasoning. Please notice that this is really asking you two questions for the answer and an explanation. I've noticed that a lot of you guys will answer the question but not explain it. So please just make sure you're explaining your reasoning. So class and school, which would be freshmen, sophomore, juniors, and seniors, and whether or not a student is allowed to stay up past 11 p.m. at night on a school night. Okay, so first we want to think about the explanatory variable. And I would say that the explanatory variable here, is the class and school. Because if you think about it, class and school kind of is the same thing as like age. And depending on how old you are, usually you're allowed to stay up later at night. So we're going to say because the class in school might help explain whether or not a student is allowed to stay up past 11 o'clock on a school night. Okay, so example B, political viewpoint, whether you're conservative, liberal, or moderate, and gender for adults over the age of 25 years old in the United States. Now, this one's a little bit different, okay? The explanatory variable here would be gender. Now, think for a second of why that might be true. Well, it's because gender might actually help predict the political viewpoint. Okay, we already know that they're over the age of 25. We already know that they're citizens of the United States. That's told to us. So the only thing that could possibly have an outcome on the other would be gender in this case. Okay, now let's talk about one way to display two variables, and that would be with the segmented bar chart. Now I understand in your printed out notes that these bars aren't very well defined. So I just want to go over this for a second. A segmented bar chart displays the possible values of a categorical variable as segments of a rectangle, with the area of each segment proportional to the percent of individuals in the corresponding category. Now, segmented bar charts are sometimes called stacked bar charts because they are a result of stacking bar charts on a side from side to side bar chart. So this right here is a side-by-side bar chart. I can't say bar chart for some reason. And this right here is a stacked bar chart. You can see that these ones are side-by-side, male, female, and these ones are all stacked by the type of superpower they'd rather have. These are actually real results from a previous year of kids that I had. I thought that you guys would think that was kind of cool. You might want to take a couple seconds because these might show up and you might just want to go around and box in some of the stuff on your work because I understand, like I said, they're not very clear because they're all kind of shades of gray. So example number 2, which gender is more likely to have allergies? So the data on gender and whether or not the person had allergies were obtained from a random sample of 227 students who responded to a survey on the Census at School website. We're going to make a segmented bar chart to display the relationship between allergy status and gender for students in this sample. So what we're going to do first is we need to find percentages. Okay, so it depends on like how we want to look at this. Well, first of all, I want my explanatory variable to be female or male. So I'm going to put female and male down here on the x-axis. Okay, now we could do a stacked bar chart or a side-by-side. I think in this case, I'm going to do a stacked bar chart because they're going to look very similar anyways. So what I'm going to do is over here on the y-axis, I'm going to put percent. I'm going to always start down here at 0, and I'm going to go by 20. So we have 20, 40, 60, 80, 100. Okay. We're also going to start a key, and we're going to do allergies. And we'll say that red would be yes, and we're going to say that blue is no. Okay, so let's come back up here to the graph right here. Okay, so we want to find what percentage of females have allergies. Okay, because we're looking at females, we're going to look over here first, and it looks like 50 out of 130 do have allergies. So that is roughly 38.5%. Okay, and then 80 out of 130 is going to be 61.5%. Okay, for males, we have 34 out of 97, which gives us 35.1%. And then we have 63 out of 97, which will give us 64.9%. Okay, so now we're going to graph these. There are 38.5% of females that do have allergies. So we're going to graph that in red. So we're going to get as close as we possibly can to 38.5. So here we have 38.5 for females, and we have 35.1, so slightly less for males. We're going to try to make these bars as equal in width as possible. And then for no on the allergies, we have 61.5. Now, because we only have 2, we know that this is actually going to go all the way up to 100%, because either 100% of the females either have an allergy or don't have an allergy. And then we're also going to go up to 100% for males. Again, you can see that this is just very close because 38 and 35 are pretty darn close when you're looking at them on the graph. So we now have made your first bar chart. And again, this is a stacked bar chart. You could have also put them side by side. They would have given you about the same information. So once we make a graph, the final step is to determine whether there's an association between the two categorical variables. There is an association between two variables if knowing the value of one variable helps us predict the value of the other. I would highlight this. There is an association between two variables if knowing the value of one variable helps us predict of the other. So if knowing the value of one variable does not help us predict the value of the other, then there is no association between the two variables. Okay. So example number 3, the data on gender and whether or not a person have allergies were obtained from a random sample of 227. This is the exact same one as the other one here. Okay. Use the graph from example 2 to determine if there is an association between gender and whether or not a person has allergies. And we're going to explain our reasoning. Now, if you look at the graph itself, we're trying to go back up. There we go. Okay, if we look at the graph themselves, they're very, very close. Knowing whether or not someone has allergies does not help us predict whether or not they're female. Knowing whether someone else is female or male does not help us to predict whether they have allergies or not. So we're going to say that there is a weak association. There is a weak association between gender and having allergies. And this is because the percent of males with allergies differs little from the percent of females with allergies. Okay, so again, knowing the gender of a person helps only slightly, because females are slightly more predicted to have allergies over males. So knowing the gender of a person only helps slightly and to predict whether or not he or she has allergies. The females in the sample, again, are only a little bit more likely to have allergies than the males. But that is why it has a weak association, because it's so little, it's really unlikely that you can tell the difference. Okay, so we're going to move on to the second section of today's notes, and that would be on relationships between two quantitative variables. Now, I do want to point out something extremely important, because it's written in bold right here, and I completely forgot to go over it real quick. Association should not be confused with cause and effect. And we're going to go over this more with different definitions a little later in this unit. So again, don't confuse association with cause and effect. So relationship between two quantitative variables. Another way that we can show this relationship is with something called a scatter plot. Now, I know everybody here has seen a scatter plot or has made their own scatter plot, so hopefully we'll be able to make some amazing ones by the end of this unit. Okay, so a scatter plot shows the relationship between two quantitative variables measured on the same individual. So the values of the explanatory variable appear on the horizontal axis. That makes sense because explanatory x, and the values of the response variable will appear on the vertical axis. Again, the vertical axis is the y-axis. If there is no clear explanatory or response relationship between the two variables, then either variable can be placed on either axis. So each individual in the dataset appears as a single point in a plot fixed by the values from both variables of that individual. Okay, so we're going to do an example. Example number 4. The table shows the number of pounds that 10 students at Gary Lang's weight training class could bench and squat. So we're going to make a scatter plot to display the relationship between the bench press and the squat weights for this sample. Okay, so what we're going to do is we are going to draw an X and Y axis here. I always start by labeling. So it doesn't appear to be a clear explanatory variable. Now, I'm not a weightlifter. I could be wrong. Somebody could be screaming at the thing, well, squat weight determines your bench press weight, and so on and so forth. But I don't think that there's a clear relationship between them. Again, correct me if I'm wrong by sending me an email. I'm totally open to suggestions on weightlifting experts here. So first thing I'm going to do, I think I'm going to put the bench press weight on the x-axis. Okay, so bench press weight, and that's measured in pounds. You always want to put the units here. And it looks like if you look up here, it goes from 95 to 196. So I think I'm going to put my numbers and I'm going to put a little break here. By the way, I need to explain what a break is. So when you cannot start at 0 on scatter plots. Because if we start at 0 here, we're going to have a whole bunch of points up here and nothing in this empty space. So what we're actually going to do is we're going to do something called a break. Now, a break, if we're going to zoom in on it, looks something like this. Okay, but you could just put a little squiggle down here so that I know that there's a slight jump in the numbers from 0, and we're going to start our numbers at actually 100. Now, I know this hurts your brain because in the whole last unit, I told you do not start at anything other than 0. But again, there's a reason behind why we don't start things at 0 when it comes to scatter plots. So we're going to have 100, 120, let's go by 20s, 140, 160, 180, and 200. Again, when you guys are making this, make sure that they're evenly spaced as best as you possibly can. Now, over here, we're going to put squat weight. And again, that is also in pounds. Now, it looks like squat weight goes from 100 pounds to about 420 pounds. So we're going to go a little bit bigger here on our axis. Again, we're not going to start off exactly at 0 here. We're going to jump off and start at 100. And I think we should go by 50s. So 150, 200, 250, 300, 350, 400. Oop, I just made enough room there. Okay, 450. Okay, so now what we're going to do is we're just going to graph these points. So the first one we have is 95 pounds for bench press, and then we have 141. So 95 is about here, 141, we'll put it right there. Okay, now you guys could put stars, you could put points, you could put smiley faces. It really depends on what works best for you. Okay, so the next one we have is 111 bench press pounds, and then 208. So 111, we'll say is somewhere over here, and then 208 is about right there. Then we have 113 pounds at 100. Let me just make sure that's right. Yep. And then we have 125 pounds at 218. Okay. And then we have 135 pounds at 284. So it's going to be up here. Okay. Then we have 145 pounds, which is at 275. And then we have 165 pounds, which is at 338. And then we have 180 pounds. I'm sorry, yeah, we have 180 pounds at 338. And then we have 180 pounds at 420. And then we have 196 pounds at 420. So here is your completed scatter plot. Okay. So how would we describe this scatter plot? Well, in any graph of data, we're going to look for patterns and deviations from the overall pattern. We're going to describe the overall pattern of the scatter plot by form, direction, strength, and of the relationship. It is also important to note outliers. So just like we had socks in the first unit to describe distribution, we're going to have FODs. It's not an actual word, but we're working with what we have to describe your scatter plots. Now, form can be used to describe a linear or curved relationship. Outliers are deviations from the overall pattern of a scatter plot, and it's called an outlier. And direction is used to describe a positive or negative or neither, and it really means slope here. And then strength can be how described as weak, moderate, or strong something is. It's kind of like how close of it is it to a line or a curve? So let's actually use FODs to describe what we have. Actually, let's go back up here and look at FODs. So first I want to look at this form. This is a pretty much straight line here. Okay, so this would be a linear graph. There doesn't appear to be any outliers. Now, if there was something over here, I mean, that's an outlier. So there doesn't appear to be any outliers. This is going up, so the more you can bench press in pounds, the more you can squat in weight. Oh my goodness, I can't talk. So this has a positive direction, and because everything is pretty close together, and if we were to draw a line, it's pretty close to that line, I would say this is moderately strong, or even really strong, actually. Okay, so let's go do some more examples down here. So example number 5, scatterplot A displays the time in seconds to run a 40-meter dash without shoes versus the time to run the same distance with shoes for a sample of 82 high school students. The scatter plot in B displays the life expectancy in years and income per person in dollars for the 179 countries in a recent year. We're going to describe the relationship shown in these two scatter plots. So what you're going to need, again, there's a reason why I make up these acronyms or I use these acronyms, is we need to look for our FODs. Okay, so I always start by writing out FODS. Now for form, if we look at this first one here, this is pretty linear. Okay, yeah, there's some stuff going on over here, but for the most part, everything else is linear. So we're going to say there is a linear pattern. Okay. And for O, those are outliers, and it looks like there seems to be an outlier around here and maybe even over here. So for the outliers, I would say this is at 8.4, 6, and I would say this one over here is at 10.4, looking, again, we're just kind of eyeballing it, 8.2, okay? So what we're going to say is there are two noticeable outliers. Two noticeable outliers. Noticeable outliers at 8.46 and 10.4, 8.2. Okay, and remember this is the time, so 8.4 seconds with shoes versus the 6 seconds without shoes. And then we have the 10.4 with shoes, 8.2 with shoes. And the reason why those are outliers is because it took them significantly less time to run without shoes as opposed to with shoes. Okay, so now we have direction. Okay, and direction is depending on like whether it's positive or negative, and I would say that this is definitely a positive association. There is a positive association, which means as the time it takes to run, how many was it? 40 meters? To run 40 meters with shoes increases. The time to run without shoes also increases. And as you can see, we kind of went into our strength here. Okay, and the last thing we have is that S, which is strength. And because the points do not vary much from the linear pattern, I would say the association is strong. Okay, so let's look at our second data point. Remember, this is the income per person and life expectancy of all the countries in a recent year. Okay, so let's see. We have FODS. Okay, so this is form. Now this is a little bit different from the other one because there seems to be some sort of curve here. Okay, this is actually, looks like a logarithmic curve, which I hopefully you guys remember from either Algebra 2 or Pre-Calculus. So I would say that there is a curved nonlinear pattern. Is a curved, you can put in parentheses, nonlinear pattern. Now, for the outliers, I wouldn't say that there's anything crazy going on here. Obviously, if there was like something down here, it would be a little out of place, but I don't see anything like extreme. Okay, so I'm actually going to say that there's no apparent outliers. There are no apparent outliers. And remember, that's because we're looking at this as a curved graph. This was not curved. I mean, these guys over here, towards the upper right-hand corner, they could totally be outliers, but there seems to be some sort of curve pattern here, which is why they are not. Okay. D stands for direction, and there's a positive association between life expectancy and income per person. So we're going to write that there is a positive association between income per person and life expectancy. And remember, that means that countries with longer life expectancies tended to have greater incomes per person and vice versa. So that's what, if I were to ask you what the direction, the positive association between these two meant, that is what I'm looking for. As income per person increases, so does life expectancy. Okay, and the last thing we want to talk about is strength. And because the points do not really vary from the curved pattern, we can also say the association is strong. The association is strong. Okay, so one last thing that I want to talk about is how do you make a scatter plot in your calculator? And we're actually going to cut to my calculator for this last part. Okay, but please follow along when I do it with this part in your calculator.
Okay, ladies and gentlemen, we're actually going to talk about how to graph scatter plots on the calculator. So here I have my graphing calculator. Now, in order to graph on the calculator, the first thing I want to do is I actually want to go to Stat. Now, Stat is a really important button, obviously in the class of statistics. So once we press Stat, we're going to come to this list. I'm actually just going to clear it real quick because I have a whole bunch of things in there from last time. Okay. And when I'm in my list, what I'm actually going to do is I'm going to plug in my X and Y points. Now what I'm actually going to do is I'm going to go back to example number 4, the one with the bench pressing and squats. Okay, and I'm going to put the bench pressing weights in my L1 and my squats in L2. So this is just going to take a couple seconds here. So always make sure I go back and make sure I don't have anything crazy going on here, like a 41 instead of a 141 or a 16 instead of a 165. Again, it just really helps if you just go back for those 2 seconds and make sure nothing crazy is happening. So now that I have everything in my list, what I actually want to do now is I want to press second and then stat plot. So second, stat plot. And the first thing I gotta do is I gotta make sure my stat plot is on. So what I'm gonna do is I'm gonna go into this first one by pressing enter. And I need to make sure my stat plot is on. I do that by highlighting the on using the left and right button here. Okay, and you see how it's blinking over on? My stat plots are now on. Now what I want to do is I want to go into plot 1, like I said, and if you look, this one has a scatter plot right there. It's a little hard, it's not really showing up on the calculator as much as I'd like it to. So what I'm actually going to do is I'm going to press that. And as you see, X list, Y list, they both show up here. Okay. Now what I'm going to do is I'm going to go down. You can make any adjustments that you guys want. You can switch the list if you want to. You can make it a different color. You all have the color ones, I believe. I'm just going to make it navy so it shows up better, and you guys can choose the size of the points as well. Now, once I have all this information in, what I'm going to do is I'm actually going to press graph. Okay, and right now, I don't know if you can see, there's nothing on the screen and nothing really shows up. Well, that's okay because I'm about to teach you the coolest trick in all of calculator fun. Okay, if you press zoom, and then you press 9, or you can scroll down to 9, but pressing 9 is a lot easier. Boom, now we have a scatter plot. And if you actually compare this to what we graphed earlier, it's not that far off. So this is how you graph a scatter plot in your calculator. It'll give you a really good idea of what the FODs are for any given thing instead of doing it by hand. Okay? Also, don't forget that this will always be in your notes just in case you guys forget how to do this, and of course the video is now up. I hope you guys have a great day, and if you guys, again, always, if you have any questions or concerns, come see me in the Meet or send me an email. Have a great day.